Welcome everyone to the 2020 APAC Groundbreakers virtual tour by APAC OUC. This year, our event would be the biggest one ever done with 174 sessions, including normal sessions, workshops, and hands-on labs from 123 different speakers over 11 days. Also, it will cover sessions on 4 different languages. Please remember to register to as many sessions you can, and all sessions would be available to replay as many times you want for 2 weeks after the initial session date and time. You can also interact with the speaker at any time during that 2 weeks by posting questions or comments directly to the playback session page. I would like to say thanks to all Oracle user groups and Java user groups that made this event possible, and also to our sponsors, Oracle Groundbreakers and CloudDB. And for today, we have Mani Sarkar with the topic NN Things Every Java Developer Should Know About AI, ML, and DO. So please feel free to write questions at any time during the session at the Q&A tab. And the speaker would answer them at the end of the session. If any issues during the presentation, please feel free to contact me at any time on the chat tab of the Zoom. Now, without any more delay, I would like to leave you with this amazing session by Mani Sarkar.
Thank you very much. So without any further ado, very happy to present at this event. I was always wanting to present at a Groundbreakers event, and this is a great opportunity for me. Thank you very much for inviting me and letting me present here. There are a couple of hashtags that I would like to share about and that you could use during the course of the presentation or after the presentation to chat over social media. To make it easier, I've actually shared the links to this slides online, and they're available as a PDF file. You can download the PDF file, or you can browse the presentation in the browser itself. If you download the PDF file, the links will be clickable. The links are not clickable while you're in the browser. So a little bit about myself, for those who don't know about me. I'm a member of the London Java community. I'm a Java developer primarily, but I also write code in other languages. And so I'd like to call myself a polyglot developer. I am a freelance software, data, and machine learning engineer. And in my day job, I work with small teams and like to say I strengthen teams when I work with them, and I help them accelerate. In my free time, I'm working on small open source projects or just open source projects in general. And if you'd like to talk more about it, I'll be happy to discuss further. I also have been honored in the last few years with these titles, and I'm grateful for them for being christened as a Java champion and later on as an Oracle Groundbreaker ambassador. Just a standard disclaimer I give during the presentations, just to let you know that I'm just sharing my ideas with you, and these are just guidelines. And and at the end of the day, your experiences may differ from mine. I also like to bring to your notice that that I'm human and I'm fallible, so I might make mistakes and there might be inaccuracies in what I'm presenting. So my apologies in advance. Also that there's a lot of resources during the presentation, and you'll notice that you could also take some of these away and do your own research at home. So I encourage you to do that, and please contribute and tweet. So we have a agenda, not too many things. As you can see, these are quite high level. We'll start off with speaking a little bit about the presentation itself, a timeline of how I started with my journey. There will be a demo. I'm trying to see how many demos I can show you, depending on the time we have in hand. And we'll close it off with some insights and shares and summary. Just want to be a bit clear before I start that these are some of the things we are not going to do. We're not talking about pros and cons of libraries or components or concepts or technologies or architectures. We're also not going to elevate some framework or library better than something else. We may talk about various topics. There might be light express of opinions, but these are done to just get the presentation started or just get the conversation or learning journey started. So we all know we are celebrating 25 years of Java this year, and there's been a great blog post written by Alexa on this topic, and I highly recommend you to go and have a look at it. There are also other related resources connected to this topic, which I've shared at the bottom right corner as a link. I've given this talk previously as well, so if you like to see that as well, you can go to the links I've provided in the bottom left corner, and you can see the slides and video. You may get some different perspectives there, but more or less the idea of the presentation is the same. So you might want to ask me, why this talk? Why such a talk, right? Why give a talk something like this? So basically, there are lots of presentations out there. There are a lot of speakers out there, and they're really doing a great job. They're really doing a great job in bringing content like how to configure something, or how a certain technology or framework or API or algorithm work internally in the deep dive. If you deep dive into it, how does it look? And some of them even do great live coding and show you productivity and how to be productive and do a great job at it. But there aren't many talks that really tell you how to become one of those individuals who have an insight into things, or how do you develop those skills and qualities in yourself that will really elevate you as a professional. And I will try to make an attempt at doing this in the next 30 odd minutes, and I hope I do some justice to it. So in my presentations, or in this presentation, I could have shown you some code, shown you some demo, some links and videos, and shared some tips, and that could be it, right? But I'd like to do it slightly differently. Instead, I want to share my perspectives on how things sit together in my experience, and also share my approaches and my methods and some of my work, and also resources that I've gathered during the whole process. So by doing this, I'm giving you a better perspective on how to ground yourself and become better at what you're doing. Also, like to let you know that we'll be cutting through various topics all across from various levels of abstraction. So we're not speaking specifically of some topic at some level of abstraction. As you can see from this illustration, we'll cover various blocks of these, and they will be from various levels of abstractions, and you will see that as I go through the presentation. So, I was asked earlier about the title of my topic, and so I think you will ask yourself, or you will ask me, why NN things? So I think some of you might be familiar with the title 97 things a developer should know, or 97 things a Java developer should know. And these two are very popular books, and there's been a lot of blog posts written on it. And I'm trying to do something similar, and I hope that I also do some justice there. So and this is something that must have happened to you, because it has happened to me. Each time we know something or learn something, we end up realizing actually there are more things around that we need to know that we don't know about. That's coming up as we go deeper into that topic. And when something like this happens, it can have quite a lot of impact on you, right? And different people will have different impact. Like some people might get an imposter syndrome, while others might feel overwhelmed with it, and yet others might feel a combination of the two. And so the way forward isn't to get stuck into these impediments, right? We might want to do something to remove these impediments. So that brings us to the question, what is AI ML DL? Now, we could have a look at the Wikipedia definition of it, and I'm sure you know of the definitions of these already. And maybe there are others out there who know even better definitions than both of us together. And we could find out those meanings from those people. But I'd like to share my perspective on it, what I feel these topics are. So in my experience, I've found them to be a mix of various topics, of techniques, of methods, and a lot of times they may overlap, but there are also a lot of times they're different and disparate and separate from each other. There are, in the conversations of these topics, there's multiple meanings and overlapping meanings that come up, but there's also misconceptions and hype in this whole area of study. And one thing I would recommend is don't fall for the hype. Do your research. Now, on the flip side, if we had to look at slightly more specific, is when we are in the process of learning to build models or learning about machine learning models, then it may be an incorrect question to ask, oh, what kind of model should we build? Rather, it'll be more proactive and practical to try to understand data more than just model building. And I have given a talk about this last year, and there's a link provided in this slide. And this brings me to also say that just building models is not good enough. We need to make sure those models are interpretable and explainable models. And I hope I will be able to touch on this in the coming slides to show you. So while I have been learning all of these things, and maybe you have come across, I have understood that there are this thing called levels of understanding, levels of abstractions, and views and perspectives and viewpoints. And so I want to talk a little bit about that in the coming slides. So we all know that the real world has a different perspective of things. A real world does not see everything. It's got a bird's eye view of some things, and it has a view up to a certain depth. And then beyond that, it's not able to see things, right? Now, similarly, if you go a little bit deeper, then when we look at the business world again doesn't have all the perspectives of all the things, right? It doesn't have a bird's view of everything, but it does have a view of a certain perspective and a view up to a certain depth. And that's something I am illustrating in this figure here. Now, if you go slightly more deeper, the technical world, again, doesn't have a view of everything, but it has a view of something from a certain perspective and up to a certain depth. And again, it may not have a full view of things above its layers, and that applies to the other layers as well, right? But now if you talk about AI, ML, DL in this perspective, and then we talk specific about what is AI, ML, DL, and we may recognize it as, okay, it's a combination of configuration, data, and code. Then that is just a small subset of the whole technical picture, right? But let's go a little bit deeper about it. Is AI, ML, DL just that? In my view, it's actually not just that. It's cross-cutting concerns across all the different layers that we've seen so far. So all the decisions and actions that we take across all the layers, from the starting to all the way to the core technical layers, these are all dependent all connected. And so we can conclude that AI, ML, DL is not just code and configuration and data, but it is cutting across all the different layers of your understanding. And so we can say that these are the realities from a basic point of view, but then there are other realities as well that we haven't spoken about, that we may not think about, but maybe others might think about. And those are also valid from those point of views and frameworks. And those are to be considered as well, and not just these realities. So I wanted to now highlight to you how did I start my journey. So let's have a look at it. Now, this is a short snapshot of the timeline since 2018 and today. So I initially started trying to learn more about these topics by coming across a lot of resources and collecting those resources. And eventually I realized that it'll be a great idea to put all of these together in a GitHub repository. And that's where the GitHub repository called Awesome AI ML DL came about. You can click on the link to find out about it. And so early in 2018, throughout 2018, I was in the process of doing this. And eventually, I also now had some knowledge to go about and start writing a library. And that's what I did in early 2019. And then I also started collaborating with people who were writing guides on machine learning and data science. And then I was reviewing their guides and giving comments and suggestions and helping them improve that content. And this also led me to give a talk on data, which I had mentioned earlier in one of my previous slides. And so in May 2019, that's when I came about writing this talk that I presented. And then there's a link provided to it, which you can go and look at. And then further on, I continued with whatever I was doing with this topic of AI MLDL, doing presentations on NLP, writing blog posts, writing example projects, and we will see some of these in the coming slides. And then later in the year 2019, early 2020, I started participating in data and machine learning competitions. And so around mid 2020, I realized that that I was able to come up with this concrete idea, and that led to developing this library called the NLP Profiler. And since then, I've been constantly improving the GitHub repository and also giving a lot of talks in this area, around these subjects. So I couldn't have done many of these things without help from a lot of indirect and direct help from a lot of different people in the industry. And so I'd like to start off by thanking Yolanda, who around 2016 and 2018 was sharing a lot of useful resources on AI MLDL on the Java handle. And she used to work for Oracle at that time. And this was really a good starting point for me. And I also want to thank at this point the Meet a Mentor initiative by LJC. Around 2018-19, the ML study group really helped me because I was able to learn a lot of things that I couldn't have learned elsewhere at that time. I cannot thank Yaz enough for holding these TensorFlow meetups in London. I attended many of them, and I have learned a lot from those events and from the sharings and the contributions and the collaborations during those months and weeks. Now, there are many, many other people who were in the journey that I'd like to thank, and in the interest of time, I haven't been able to do that, but they are in my mind. So you will now ask me, okay, how do I learn, right? That's an interesting and important and useful question as well. So this is more or less sums up. I follow the top-down approach, which is an outside-in learning approach. And it's similar to what FastAI is also advocating. And if you watch this talk by Rachel Thomas, I highly recommend doing that. She talks a lot about the concept and the idea and the approach. Now, I just don't collect links and lists. I do a lot of mind mapping. I gather reading material. I organize them. I categorize them. And this helps me build something called a nodes of knowledge. And I've spoken about nodes of knowledge in my previous talks. I've presented a link or two here. And there's also this topic called automatic chunking. And Coursera has got a great course called Learning to Learn. And this is something also I would recommend you to have a look at. So you'll actually say, okay, you're just building static links and putting them on GitHub repository. What's the benefit of it? What's so great about it? So I'll actually beg to differ on that. Is building a list like that helps prioritize and order topics and things that you like, that you want to learn, and maybe even cull topics that you may not be interested in, or you don't like, or it's not of importance. And this helps build a landscape and an understanding of the context of the field of study or research in my point of view. And then this gives you a bird's eye view of that field or of that topic or of that subject. And this is fairly useful and helpful. So we spoke about the GitHub repository earlier, the AI-ML-DL. Let's dive a little bit into it and see what's all in there. So this is the link to the repository. I highly recommend go and star it, watch it, fork it, share it with others. And this will help me motivate, continue doing what I'm doing, but also it'll help you learn and keep in touch with all the useful and important topics that are out there. So let's go see a little bit about what I have been doing with this repository. So in the process of gathering links and categorizing them, I discovered a whole lot of these high-level topics. And these are actually the non-Java related ones, but this is a huge corpus of the repository. I also wrote a blog post about this, which you can also read and find out more. Now, they were not just non-Java links, there were also Java-related ones. And so if you see here and you're interested in knowing what are the things and topics around the Java space that you should know about. And these are quite a few of the high-level topics. I'm sure you'll be interested in natural language processing and some of the libraries, the Java and JVM-based libraries. that you could use to do that. There are a lot of Clojure and Scala resources that you can dive into. And I did not know this, but there are JSRs being worked on at the moment that you might want to also look into and maybe participate. So I was not just about collecting links and putting them on a page and then publishing them on GitHub. I also created things that I call them artifacts. And what are these artifacts that I created? So for example, whenever I would give a presentation, I would have to create an example. But I was also creating examples of things that I was learning about. And then examples would lead me to create notebooks. And then they would lead me to create Docker containers. And then I would also have study notes that I was collecting and I was putting together separately. And then in the process of doing all of this, I would come across a lot of people's shares that would like cheat sheets shared about different topics, and I would gather them together and I put them together in a particular category. And then there were guides that I was reviewing and writing and collecting them in another category. And this led me to also come up with this list called things to know, because imagine you have a whole tree or a mind map of these topics. They're going to be really hard to navigate if you want to know some of the high level topics, right? So the things to know list is a really helpful quick list to navigate through in case you want to find out some of the important things that you should know about, and then where to go from there. So these links are all live. I recommend you to click on them and find out what they are, and you can see some of my work there. Now, there's nothing like learning by example, right? And so this is exactly what I'm wanting to share, and this is what I've been doing as well. So earlier I mentioned about creating those examples, and so this is what I was doing. As I was learning, I was creating these examples, and I was working on those examples further, which helped me learn further. And so these are some handful of links of the examples that I've created in the last 12 plus months. And I highly recommend you to go and have a look at them and see and run them yourself and play with them and learn from them. And then there are blog posts written as well for many of these that you could go ahead and read and further learn and maybe write your own posts from that. Now, the bottom two links are not created by me. They are works of other entities, like, for example, NVIDIA wrote this Graal CUDA implementation using Truffle, and using that you can communicate with GPUs on the JVM platform. And similarly, Graal Python is a Truffle implementation of Python that runs on the Graal VM. These are examples that you might want to look at and play with. So with that, it brings us to a point where I could actually show you some work in action, because I've been talking about things and showing you links, but I would also like to show you some code and show them running. So here's a link or a set of links to the demo that I'm going to be presenting. It's basically we are building a regression model from a data set, and we're using this library called Tribio. And these are the links to the various artifacts. And you could also do this yourself by going to the first link and following the steps in there. And I'll actually walk you through the notebook right in this demo here, so you can see how you do it yourself. And I have some other links that will show you, and links to videos that will show you how to do this for other types of notebooks. So I have given a similar demo last week at another presentation, where I introduced Tribio, the Java ML library. And at that presentation, I did this tutorial on the classification model. And so I'm not going to do that today. Instead, I've picked up the regression model. But if you'd like to see more of what I've done in that presentation, this is the link to the slides. And the video should be available soon, but the slides should help you find out more about this library, and also how to use the example and the classification tutorial. So just a little bit more about what the demo environment is going to be like. So I'm going to show you a notebook, and the notebook is actually be running on this server called the Jupyter server. And the Jupyter environment is actually quite flexible and open environment, an extendable environment. Primarily, it was meant to only run Julia, Python, and R code, but the way it's been designed is you can write a kernel that's Java-based, or any other language, and then that kernel can support the language in the notebook, and then you can basically write code in that language, and the notebook will interact with you in the exact same fashion it would interact with other languages that it supported. In this case, we will be running the Jupyter environment with the iJava kernel, which talks to the Tribio and other Java libraries through the jar files, which are running on Graal VM at this instance, but in your case or any other instance, you could use another JDK. And that's, in this instance, is running a Docker container, but you could also run this in a native environment. And as I was mentioning earlier, the notebook file will be served into the browser. So we'll be using the browser as the interface. So you might ask me this question, so what is a notebook, right? So I'll say in short, a notebook is a combination of the best of both worlds, the REPL development world and the code build run world, which we all used to. And we both switch between both these worlds from time to time. And some people stick to one mode and then the other. In the notebook, you can do all of those things you can do in all the environments. And then the added advantage is you're able to save all your output and share it with others in a collaborative fashion. And so the notebook is best of both worlds plus more. So I've shared a couple of links, including a video of a demo of a Java-based Jupyter notebook, which you can see separately as well. So I'll be running this notebook in a second, but these are the screens you're going to be witnessing on the presentation screen. And so just wanted to bring to your notice some of the things you might want to look at when you're doing the demo yourself. And so let's get to the demo. But before that, I'd like to share that this is the regression tutorial we'll be going through. Basically, what we're doing is we're going to build a machine learning model that reads a data set that has got 9 to 10 characteristics of various wines. And also it has got a target variable or a label that assigns the quality of that wine. And so we're basically building a model that will be able to detect or let you know or evaluate wine and let you know what the quality is. So let's get started with the demo. So I'm going to be switching to the terminal. And so as I was mentioning in the screenshot, this is the command I'm going to be running. And as you can see, as it kicks off, it'll open up to run the Docker container, and it opens up the browser and it shows me the different things that I want to see. In this case, it will show me the Jupyter console, and this is the view inside the container, and we know where we want to navigate to. We're going to go into this folder called Tribio, and therein there's another folder called tutorials. And the tutorials folder has got a whole number of notebooks. You can see the IPYNB extension files. And the notebook we're interested in the regression notebook. But I'd like to also quickly tell you about what the other things we have. We've got some data files that we have downloaded and placed them next to the notebook. And this is our wine quality notebook, data set that we'll be using in the regression notebook. And there are also a number of jar files. We'll be using some of these, and you will see that in the notebook in a second. So let me go and open the notebook for you. And so this is the notebook. What I will do first is I will clear all the outputs so that you know I'm running the notebook from fresh. Now in the setup, it says we need to do a wget. We have already done that. I'll quickly let you know now how this works. So this is what the notebook looks like. These are called cells, and you can write code in the cells. Now in this instance, you see there's something that you might have not seen previously. Is in the world of Jupyter, this is called cell magic. And so a cell magic is written with a single percentage or a double percentage. In this case, it's a single line. So it's a single percentage and then a keyword and parameters after that. In this case, because we are running Java inside a Jupyter environment, and in this case, we need to also access the library that we want to use in the notebook. We need to load the library and the library is in the form of jar files. And we need to load the library into the environment. And the way we do it is we do it in this fashion. We place our cursor on the cell and do Shift Enter, and it loads the library. In this case, these 4 jar files are now loaded in memory, and all the packages that are related to these jar files are now available. So when I do Shift Enter on the next cell and the next cell, you can see they just execute without any problem, which means it's all in place. Now we need to load the data set. So the data set is loaded. Before we load the data set, we need to instantiate a class called the CSV loader, and we need to pass it the right parameters. Now the data set, if you haven't seen, and I'll show it to you quickly, is actually a semicolon delimited file. And you can see from here, the semicolon separating each value in here. These are the names of the columns, as I was mentioning earlier. And this is the last column, which is the target or label column that is called quality. And the others are the feature columns that are going to be used to create the regression model. Now, going back to the notebook, I will load the data set. So let's instantiate the CSV loader. And so when you're loading the data set, we will see that we need to pass in the name of the raw file, and also the column name that is going to be a label or a target field. And when we create a data set, we actually make sure that we split the data into training and tests, because when you're creating a machine learning model, we need to create the model from the training data and then evaluate the model using the unseen test data. And that's why we're splitting this data set into two parts. And so here you go. We now have a data set that has got the training and evaluation data, and we split it by 70-30. So there's 70% training data, 30% evaluation or test data. Now, someone who's written this notebook has done a good job of putting the core functionalities in methods. And in this function, which is a training function, the two important lines of importance are this, that trains the model, and here that evaluates the model. So basically, you can see here, trainer is an instance that is an algorithm that we are going to use to train a model, and we're inputting the training data into it. And then when you run the train method on it, it produces an instance called model. Similarly with evaluate, you pass it the model and you pass it the training data. So this is training evaluation we are doing. So you pass it the training data, and then it'll evaluate the training data and give us the metrics of that. And similarly, there's a function written to evaluate the model that we have created using test data. And so we're doing exactly the same thing. We're creating an evaluation instance, and then we're passing the test data, and we're printing the metrics. Now, this specific case, the model has been created. There are 4 different types of algorithms or 4 different instances of model algorithms created here with different parameters. We won't go into the details of it, but skimming over, we can see there are 2 types of linear regression models or algorithms used to create with different parameters. And then there are other 2. One is a tree-based model algorithm, and the other one is an ensemble-based model algorithm. And you might be familiar with these, but we will see in the coming slides in case you're not. So let's run these so we know that we can execute them as we go further. And so I've run that, and I've instantiated these 4 model types. And now you see when we train the model, it evaluates and shows us the metrics. Now when we further do the evaluation, it'll also do the same thing with the evaluation data, and we see the metrics here. I'm not going to go into the details of the metrics. There's nice definitions mentioned here, including the Wikipedia page, and I highly recommend you go and read about them. Now, this is another model algorithm which we saw, which is using the ADA grad optimizer. And as you see, that again ends up creating the evaluation and test, training evaluation and test evaluation data. Now, let's run the CART model, and that again does the same thing. We have another model created from that algorithm, and yet another model that does the XGBoost, that's using the XGBoost algorithm. So we've now gone through the simple code that actually takes in data, takes in model algorithms, and creates models from them. And it also evaluates these models to tell us how good they are. So the metrics actually gives us a snapshot of the accuracy of the model. How well does it understand wine quality? So let's go back to our presentation again and see what else we can see from these models. So this is a repetition of the metrics information. As you can see here that I've expanded on these, but the Wikipedia page and the evaluation models section in the notebook, they do a great justice to it. I've provided those links there as well. If you want to deep dive into them, then you can go ahead and do that. The reason I'm showing you here is you can see from the different outputs, and I've highlighted the RMSE scores here. Ideally, RMSE 0 is the perfect model, but you'll never ever have an RMSE 0. but something close to 0 is what we are trying to achieve. And you can see as we progressively move to better algorithms, the RMC score is dropping and getting closer to 0. Now, it's more the test RMC scores that I'm usually interested in, and not the training one, because test one is with unseen data, and the real world data is going to be unseen data for the model, right? So that's something to take a note of it in this instance. I've also provided links to the AdaGrad, CART, and XGBoost model algorithm types. So I couldn't show you all the demos of all the different examples that I've been working on and that are interesting. So I have gathered a whole bunch of them that you could do yourself. And so there is a client app, a Java-based client app that you can run, which does the same thing as you saw in the notebook I showed earlier, but you can run this from the command line, and there's a Java project written and with both Maven and Gradle configuration files, and it's pure Java code, and there's a lot of print output, so you can actually see what's happening at every step. And I highly recommend you go and look at it, because you can build and run the Java files from the command line, but you can also build and run GraalVM native images from the command line. In the previous time when I gave the same presentation, I had shown a chatbot conversation presentation, but this time I've left it for you to do. Here's the link, and all the instructions are there on the GitHub page. You also have questions and puzzles to solve, to do some thinking about it. And in case you still are wondering how to go about doing it, there's a link of the video here that I also highly recommend you have a look at. And this is more or less what your screen would look like. In my case, I tiled all the panels together, so this is what it looks like this. But you could have them separately, but your outputs will be more or less the same, and you'll see why it is the same. So I wanted to do a slight closing of this session by saying Java is a tool. It's a programming language. All the amazing things you see done in other programming languages by other developers are all possible and all doable in Java itself. So putting together this presentation and learning all these things led to gathering a lot of resources and reading through a lot of different resources. So I've put them together here in this section. You won't need any more than 5 of these links, I would say, to get started with learning more about AI, ML, DL, because these are great starting points. I have made some contributions in the bottom 2 links, but the top 3 links are creations of mine, and all of the things I've gathered so far, I've placed them there. And I would think that these are great starting points for you as well, if you're going to be embarking this journey. I've also gathered together Java-specific AI, ML, DL resources, and you can see from the names itself that they are going to be useful for you, and hopefully they are good starting points, if not even research material to enhance your existing knowledge. Now, there are other Java ML libraries out there, not just the ones I've talked about and shown. And so there are some more links here. EL gave a presentation recently, and he spoke about other ML libraries. And he also spoke about Tribio, and you can see that in the presentation. Zoran has written a blog post on ML libraries and his own library called DeepNets, and I highly recommend you to check it out as well. I've spoken about these previously, and I've provided the link to the talks there. And during the next this week and the coming week, there are going to be lots of different talks at this event itself, and I highly recommend you go and have a look at the schedule and pick such topics for yourself to learn further on this. So I could have added more resources on this slide, but I didn't want to flood it with more links, and so I've added them towards the bottom of this presentation. And if you go to the appendix section, you will find more useful resources there. So I'd like to summarize now, having spoken for 40 odd minutes now already. I wanted to share my journey with you and the topics I learned, and I've done that in the last 40 odd minutes. And I wanted to let you know that if we organize ourselves, we can get better results. And try to create simple things from scratch, similar to the demos that I showed you and the examples that I talked about. And you will be surprised to know that how simple ideas can go very far and inspire others with creative solutions. And this is a repetition of all the things I've already said so far, but I hope that the resources I shared are going to help you learn further and also overcome some of the impediments and some of the blockers that you might be facing, some things like that make you feel overwhelmed, or removing and avoiding the imposter syndrome. Just a closing summary is the path to mastery or championing a subject means we got to do things differently. We got to take different approaches. Do all the things you already know, do all the things you already see done, but also do other things and take different and other approaches. So with that, I'd like to thank you for being here. And if not at the event, but then watching this video, but also thank the organizers for putting together this event for us. And please use the hashtags mentioned here to talk more about this presentation. I'd like to do a quick citation that I've used artifacts and images in this whole presentation, and the respective authors and creators remain the original owners of them. With that, I think there's barely 30 seconds left for a Q&A. If there are any questions in the chat session, or if anybody likes to add a question or two, then I'll be more than happy to take that and answer them for you. And I've got some social media links as well that you can then follow from here. Do we have any questions coming in that we know of? Anything in the chat?
No, nothing in the chat. And it's your last chance to ask your questions.
Exactly. I hope you guys have been able to see the slides well and hear me well as well. And there has been no audio-visual interruption in the process.
Yeah, thank you very much. Thank you everyone for your participation today. And please do not forget to register to another great sessions in the conference and to interact with the speakers in the playback session page. Please enjoy the rest of the conference. Thank you.
Thank you.